Welcome to the last unit, or last part of our unit on magnetism. In this unit, we're going to be recording it a little bit differently because I need you to be able to see my hand, which I can't show you in my normal method of recording. And the reason for that is because this unit, we're going to be learning right-hand rules. I'm going to be doing a lot of examples of how the right-hand rule works. So, to begin, I'm going to start with what I call right-hand rule A. The purpose of right-hand rule A is for finding the direction of the field due to a current carrying wire. When using this rule, you put your thumb in the direction of the current, and then you curl your fingers to give you the direction of the field. I have two examples on this page and then more on the next page. So for this one, I say I have current coming out of the page, so I'm going to stick my thumb so it's pointing out of the page up at the camera. And now my fingers curl around and they're forming a counterclockwise circle around my wire. So since it's counterclockwise, my magnetic field would be like this. On the other side of the page, I have a current into the page. So if I stick my thumb pointing in, I now form a clockwise circle as I move my hand around. So this magnetic field will point in the opposite direction. Next set of examples. Okay, so here I have four different currents. I'm going to start with the one on the top right side of the page. So my thumb goes in the direction of the current. That's this one. Thumb in the direction of the current. So now my fingers are going to give me the direction of the magnetic field. So above the wire, they point downward. They would curl around underneath and then point out of the page on this other side. So we're going to get a circle around the wire. Above the wire, they point down and in. Below the wire, they point out. If I were to look directly above the wire, it would be pointing towards the top of the page. Directly behind the wire would point towards the bottom of the page. The other side of the page here, current is to the left. So my fingers come out of the page above, would curl around, go into the page below. So it's exactly opposite the other side. Out of the page above, into the page below. Directly above the wire, it would point towards the bottom of the page. Directly below the wire, or under the wire, if you will, it points towards the top of the page. And remember the arrow notation. This means out of the page. This means into the page. And just trying to get us on the same page, if you will, regarding directions. This is to the right. This would be to the left. This one is to the top of the page. And this one would be to the bottom of the page. Okay, moving on. I'm going to do this one next. So my thumb in the direction of that current, so towards the bottom of the page. To the left, my fingers point in. They would curl around and come out on the other side. So I'm going to get one of these. On this side, they pointed into the page. On this side, it pointed out of the page. Directly above, it would point this way. Directly below, it would point that way. Okay, last one. Thumb in the direction of the current. Goes in to the left, would come out on the right. So again, into the left, out to the right, and directly above, it would point that way. Okay, that is right-hand rule A. Moving on to right-hand rule B. Right-hand rule B is for finding the force on a moving charge. Okay, this one works a little bit differently. So you start by pointing your fingers in the direction of the velocity. You then curl into the direction of the magnetic field, and your thumb will give you the direction of the force. Now, I say this, if in the process of trying to do these, you think you need to be Gumby, adjust things so it's comfortable. So right now, I can't get comfortably to where my fingers point in the direction of the velocity. So instead, what I'm going to do is I'm going to rotate the entire page. Now I can easily point in the direction of the velocity. This tells me that the magnetic field is out. So what I'm going to do is I'm going to rotate my hand such that when I turn my fingers upward, or turn my fingers so they point 90 degrees to my palm, they now point out of the page. My thumb gives the direction of the force. So the force on this particle would be towards the bottom of the page. Okay. Rotating back around. Just to show you how it wouldn't matter about the orientation, let's do that one more time. But instead, we're going to rotate another 90 degrees. So fingers in the direction of the velocity. My hand's already positioned so that I can rotate my hands so they point out, or rotate my fingers so they point out of the page. The force is towards the bottom of the page. Okay, so reorienting does not change the result. Okay. Next one, we have a velocity this way. Okay, so I'm going to come in like this. I'm now going to reorient my hand so that I can point my fingers towards the top of the page. My thumb points downward. That would be into the page. So I use the tail of the arrow notation. Again, this is another one where it's not comfortable for me to do as it's shown. So I'm going to rotate. Velocity is this way. Field is in, so the force would be towards the top of the page. This one is slightly different because instead of giving you velocity and field, I'm giving you velocity and force, and you need to determine the field. Okay, so again, I'm going to rotate just because it's easier. What I know is my fingers have to start pointing in the direction of the velocity, so that's this way. Now I need the force to come out of the page. That means eventually my thumb has to end up pointing out of the page, so that's up at the camera. Okay. Now, what direction do my fingers need to point in order to make that happen? My fingers would point towards the top of the page. This tells me that the magnetic field must point towards the top of the page. Okay, so now let's check it. So I point the fingers in the direction of the velocity. Magnetic field towards the top of the page. So now my fingers point towards the top. My thumb again points out, which is the direction of the force indicated. Okay, lastly, right-hand rule C. Right-hand rule C is very similar to right-hand rule B, but instead of pointing along the velocity, because you don't have a velocity vector, you point along the current. But really, the current points in the direction of the velocity in a lot of ways. And so it's very similar. So again, we're going to point our fingers at the direction of the current. Then we're going to curl into the direction of the magnetic field, and our thumb again is going to give us the force. So in this case, my current points this way. The magnetic field is out, so I'm going to rotate my hand so my fingers can point out. And my thumb is going to point downward. So the force on this wire would be downward. So that would mean that it would bow down like this, assuming the endpoints there are connected. Next slide, I have a bunch of examples. Okay, so I'm going to start by rotating 180, so I can do this one. Fingers in the direction of the current. Rotate my hand till I can point in the direction of the field. My thumb points out of the page. I'm going to, let's see, do this one next, I think. Current points out of the page, so that means I have to point my hand upward. Then I have to point in the direction of the field, which is, I guess, towards me at this point. And my thumb is going to point towards the top of the page. Rotating again. Fingers in the direction of the current is in. Field is that way. It's hard to see here because it's underneath my hand, but my thumb points downward. not a huge surprise for that one because it's exactly opposite the one above it. Okay, lastly, fingers in the direction of the current. Rotate your hand till you get the velocity, or till you get the field. And then your thumb gives you the direction of the force. The force is, in this case, inward. Okay. So lastly, let's look at what happens when we have current carrying wires and how we get those forces. So I'm going to begin by labeling my wires A, B, C, and D. A and B have parallel currents. C and D have series currents. Okay. Okay. This is a multi-part process, and I'll write it down as I go. So I'm going to start with A and B. So step one is I'm going to use right-hand rule A on wire A to find the magnetic field at wire B. Okay, so again, easier for me if I rotate, so I'm going to start there. So right-hand rule A was thumb in the direction of the current, so my current is that way, which tells me at B, the magnetic field due to wire A is pointing into the page. The magnetic field due to A points into the page. That's step one. Step two is to use right-hand rule C on wire B to find the direction of the force. Okay, so right-hand rule B says stick your fingers in the direction of the current. So the current on wire B is going that way. Curl your fingers into the field. The field is into the page, which tells me that the force is going to be this way. So this is the force from wire A on wire B. We can do the same thing in reverse for finding the force from wire B on wire A. And the steps are the same. I just have to switch which wire I'm talking about. So I'm going to begin by using wire B. Put my thumb in the direction of the current. Curl my hand at wire A. It is coming out of the page. Now I'm going to use the current of wire A. Rotate my hand until I can point in the direction of the field. The field at wire A is upward. So the force is the opposite direction. This should not surprise you since they are a third law force pair. Okay, let's work now on wires C and D. So I'm going to rotate around like this. Same two steps. You begin with one wire and then find the force on the other. So I'm going to begin with wire C, thumb in the direction of the current. My fingers curl up on this side and would go down and in over here. So this would be the field due to wire C. Now I use right-hand rule C on wire D. Fingers in the direction of the current, curl into the field. The force is this way. Okay. We can repeat this process for wire C. I'm going to stick my thumb in the direction of the field due to wire D. Right-hand rule A tells me that I said that wrong. Stick my thumb in the direction of the current due to wire D, or in wire D. Curl my fingers, and that tells me that the field at wire C is into the page. I think I wrote that one wrong. We'll look at that in just a second. So this should be the field due to D over here. It's going in, right? That's what we determined, yes. Okay, and now rotating again, dreadfully sorry. Fingers in the direction of the current, field is in, force is the other way. Okay, let's make sure I wrote that symbol wrong, because I think I did. So this, that, yes, I think I did it all correct. It was correct. It was drawn correct. Now let's just check the last field. Current field, yes, it's okay. It actually is exactly proper the way I did it the first time. Always reassuring. Okay, I will scan this file and post it for you on Sakai. I hope this helps you understand the right-hand rules, and this finishes this unit.